And the next session will be NIS1002. Professor Carlos Moreno. Can you hear me?
Yes, sure. Do you hear me?
Yes, I can hear you.
Okay, I'm going to share my screen now.
Okay, if you're ready, to start now.
Wait. Please. 1 second, please. Okay. Here. Can you see my slides? Yes?
Yes, we could see a slide.
Okay.
Okay.
Wait, I'm going to use my watch. Yeah, wait. Okay. Good morning, everybody. Nice to meet you. My name is Carlos Moreno from Venezuela. The name of my presentation is Study of the Effect of Security on Quality of Service on a WebRTC Framework for Video Calls. Been the project of collaboration between Universidad Politécnica Salesiana de Ecuador, IT Business Solution DEF Enterprise from Venezuela, and San Logoyo Institute of Engineering and Technology from India. And of course, I'm professor at Universidad Central de Venezuela. The points of my presentation are the following. At first, motivation. Second, state of the art. Third, formulation of the problem. Fourth, methodology. Then, results and analysis. After, we will have conclusions and perspectives, some previous publications, and questions. Let's begin by saying that between the years 1990 and 2021, there has been a process of convergence where traffic of video, data, and voice are on the same platform. Some signaling protocols have been created, like H323 from ITU, SIP from IETF over IP version 4, IP version 6, some peer-to-peer algorithm, de facto standards. And we also have the architecture WebRTC standardized by IETF and W3C. We also need to take into account that quality of service and security are very important over the platform, but which is their relationship? This is the focus of our research. We can have WebRTC over an NGN, over Wi-Fi, 4G, 5G, eventually 6G and other generations. Regarding the state of the art, when we speak about quality of service, to our minds comes latency, jitter, packet loss rate, delta, which is the separation between frames, consecutive frames, response time. Regarding security, we speak about confidentiality, authentication, integrity, and non-repudiation, which is the relationship between both worlds. And WebRTC architecture has two planes, the planes of signaling processes and media. The signaling processes, they use TCP protocol on the transport layer. They can use TLS for ciphering, authentication. And on the media plane, we can use DTLS. And for video and audio, we could use SRTP. In our work, we didn't use SRTP, but we use DTLS. And we can also have a data channel for data. And this, the first implementation was in May 2011. It's in the process of standardization since then. Some work has been done to relate or establish the relationship between quality of service and security, but some general work only has been done. For example, on the first work, some sub-services are modulated. And we take into account the security as part, the security as part of the quality of service. Second, some KNN file classification for security cloud infrastructure has been created. We define levels of security and how the quality of service is on each level. Then we have studied the quality of service on the cloud and how it can be related with the security. And in the case of wiretap cognitive radio networks, two other papers, important papers, try to explain, for example, what factors influence the quality of experience for WebRTC video calls, and some work has been done about this. But we speak about quality of experience. Quality of experience is farther than quality of service. And we also have some work that has been done trying to test the quality of service on WebRTC. We also have some frameworks regarding legal issues. The most important one is Y1541, which is the objectives of network functioning quality for internet protocols. But of course, some definitions are here and some other more specific definitions here. And G114 for the one-way transmission time. Regarding the security, we also have some recommendation from the ITU regarding the security architecture for interconnection of open system. And we also have X1051 about information technology. So some framework has been created. Now we've had two research questions. How does security affect quality of service indicators in LAN and WAN WebRTC scenarios? Second question, do quality of service indicators maintain with the recommended values when assuring signaling and media traffic on WebRTC? We had 4 test beds, 2 over LAN, 2 over WAN infrastructures. For the WAN infrastructures, we used the national ISP of Venezuela, which is CANTV, which uses DSL access technology. And the results were analyzed by my team from Venezuela, Ecuador, and India together. So we arrived to the methodology. At first, let me tell you that we had 4 test beds. The first 2 were on LAN networks. We established 25 calls per security level. We had 3 security levels. The first one without security on the higher levels. The second level is with TLS on signaling messages. On the third level, we had security on signaling messages with TLS, but also DTLS over media. We use the ISCSIC project, which is an implementation of WebRTC. We use also the Google Canary browsers to establish these calls. We installed the Node.js, and here we had the signaling server. At the right side, we had the same testbed. The difference was only that we called from a PC to a smartphone model LG K10. The other 2 scenarios were over the WAN. The only difference is that we used the connections with CANTV, the ISP from Venezuela, with DSL technology. We also had 25 calls per security level at left side, and we had 25 calls also at right side. So we had 4 test beds. On every test bed, we measured the establishing time as the difference between the instant when we send the first message start request and when we receive the first UDP RTP media packet. We did this on the first level, second level, and third level with security. We use Wireshark to catch the packets. For the leaving time or termination time, we measure the difference between 2 instances when we send the last stone binding and we receive the last UDP RTP. We did the same thing for the first, second, and third level. We arrived already to the results and analysis. At left side, we can see that we had the 4 test beds. The worst cases for the establishing time was on the second and on the fourth scenario. It's very normal because on the second and fourth scenario, we used smartphone, and on the fourth one, we are using the WAN. So we have more chaos here, right? But we can observe that on the second scenario, we have an improvement on the establishing time. We have more security because we're ciphering the signaling processes, the messages, and also the media processes. And we have less time response. And on the right side, we have a similar behavior on the second and fourth. They are the worst cases. And we also improve the duration or living time from the second level of security and the third level of security on the second one. So something is happening here that has been studied. Regarding the jitter has been improved on all the scenarios. According to the recommendation Y1541, it must be lower than 50 milliseconds on classes 0 and 1. According to the best practices of, for example, the enterprise Cisco systems, among them, the video jitter must be lower than 30 and 50 milliseconds, and voice lower than 30 milliseconds. We comply with that. And we can see also that there's an improvement between the second level and third level of security. It looks like the ciphering processes need a buffering that acts like a quality of service buffering. It could be one of the reasons why we have a behavior. And also because we use the RTP. RTP protocol uses quality of service for the congestion control. Regarding the delta max, which is the maximum separation between consecutive frames, according to some white papers like this one at right side, the max delta and jitter are somehow correlated. And we can see at left side that it has been improved on the second test bed and a little bit on the third test bed. Here at right side, at left side, we studied the audio. And for the video, the behavior is a little bit different. But somehow on the second scenario, we have an improvement also. It looks like depending on the type of traffic, there could be also a little bit difference. And we use machine learning at this time to detect clusters. At left side, we use machine learning to detect clusters for the first, second, and third levels of security for the first scenario. This is the only experience that we have with machine learning because this work tries to recommend the use of the machine learning, but we did it with Weka, the same software that has been used by my previous presenter, a very good software for that. And we also did the same thing for the video, and we found that the clusters move from the first level to the third level. But in the case of video, it moves less. So it's one of the conclusions of our studies for the first. Of course, we want to do that for the 4 scenarios. We did the same thing for the establishing time and living time, because in the previous graphic, we had two features, delta max and jitter. But here we use 2 features, setting time and living time. We saw this phenomena. Clusters move from 1 to second level of security, and we arrive to the third level of security. So we arrive finally to the conclusions and perspectives. The relationship between the levels of security and quality of service depends on indicators. It's not absolute. And it depends on the indicators and protocol for scenario study with our framework in ISCSIC2021, where WebRTC is implemented. Second, the security over signaling plane influences time response, while security over media plane influences response time, jitter, separation between the packets, which is the delta. Third, we have concluded that the quality of service indicators are within limits recommended by ITU and best practices for the scenarios study. This is very important because we always ask if our architectures comply with the recommendations. And Delta Max is more affected on video traffic than on audio traffic. Of course, we use the codecs of WebRTC, which are OPUS for audio and VP8 for video, respectively, of course. We could try with other ones. The following conclusion was that K-means can be proposed to detect the clusters as we did it. We did it for two features, time response, joining and leaving time, and we did it for jitter and delta, but we tried for the first scenario only. We are going to do that with the second, third, and fourth. And we should take into account other additional indicators like packet loss rate and latency. And we should consider also the study of different codecs for audio and video because perhaps the compression has some effect. So we're right to the publications. Previously we have worked a lot about how the security affects the quality of service on a spatial architecture named SIP multicast, which I developed during my PhD in France in 2009. And we have studied a lot about how the security affects the Wi-Fi in the Internet of Things. And we have some work which has been done with my colleague from India. And we have done some work about this and presented in Security 2001. In that time, we didn't do the experiments with machine learning, and now we did it, for example, for the first scenario. So finally, we arrived to the questions. I'm very glad to be with you now. Thank you very much for your assistance, for your virtual assistance, and I would be very glad to answer any questions.
Thank you, Professor. Is there any question? If you have any question, you could turn on your microphone or put your question as the chat box